10,000 feet. We drop about 20 of them. They're about $750 a piece. We'll drop them in the eye wall as we're going through the eye wall to get the max wind speed. We'll drop them in the center of the hurricane once every 6 hours as requested by National Hurricane Center so that they can get a basic track of where it's going. The reason why we drop these is if you look at this chart right over here, this gives you a good indication of why we do what we do. The orange graph line there is the predicted track of Katrina without us flying, just using satellite and radar imagery. The black line is the actual track. The green line is us flying, dropping these, and they can predict where it's going to go. So you can see the actual track, and you see the predicted track. So, you know, it's a valuable asset throwing these out, even though they are $750 a piece. We'll throw average about 20 out per hurricane flight. So once they hit the water, they're done. You know, we don't retrieve them. They start to biodegrade, and it takes several months actually for them to degrade. But yeah, so once they're gone, they're gone. Yeah. So and all that information comes up to this console right here, and then we send all the information out via satellite link to the National Hurricane Center, and they crunch all the numbers, put in their models, and then that gives us the forecast. So that's basically what we do. We also have a G4 that flies at 45,000 feet that drops these out, but they fly outside of the hurricane, around the edge of the hurricane. And that gives a good indication of the steering currents in the upper atmosphere, of how the upper atmosphere, the winds are going to steer the hurricane. We also drop VTs out, which measure the water temperature of the ocean, and based on how long it falls through the different layers of the water, and based on how long the temperature remains at a certain temperature, they can tell how deep that water is. And if it's really warm, it's deep, then that means basically the hurricane's going to either maintain its strength or intensify. So, any questions? Feel free to take pictures. Nothing classified except for me.
High tech they are. Newest technology of 1984.
Yeah.
And a lot of this.
Oh, your 3.5-inch disc drop. That's your key there. That's your clue.
And I can top it. Does anybody know what this is?
Oh, DAT
tape. Yep.
Yeah.
For those of you that don't know about these things, these were the new technology when they were somewhere between cassette tapes and CDs.
Right.
These were the hot new technology that was going to put everybody out of business. And now we are the only people on the planet, I think, that still use them. But they are nice because we don't have to worry about them skipping like a CD would, which, you know, of course, we can slam around a little bit, so it wouldn't be any good. Cassette tapes really don't last long enough, and I don't think they even make those anymore. And I think that us in the Hurricane Research Department are the only ones who actually use these anymore. They've got thousands of these things that we recorded. Anytime we fly, we'll record. So everything's saved both on hard drive on here, believe it or not, and on these tapes. We have two, one's just a backup for the other. One's not even powered. If I have a problem with one of these, I just flip over to the other one. Everything comes in here, it's packed out to all these monitors all over the aircraft, and it's also transmitted down to the deck. So they're getting real-time information. We actually transmit about every 15 minutes, send down all the information that we've gathered. And we also have the capability to send down any other messages that we want to. Everything ties in right here. We have 3 radars on board. We have a color weather radar that's up in the flight station, just like any airliner would have. Then we also have, if you saw the M&M on the bottom of the airplane, there's a 12-foot radar dish in there. It's gold-plated. Rotates about 10 to 12 times per minute when we're in the air. And it just allows us to see what's going on out there, find the hot spots in the storm that we've been looking for. We also have one in the back, on the tail of the aircraft, that actually rotates this way. You know how most radars rotate this way? We have one back here that rotates this way. That's purely a scientific radar. It's a Doppler radar, just like you'd see on the Channel 5 news or whatever. And the display on that one's kind of crazy. It's hard to read, but the scientists get a wealth of information from that. So it's very useful. That's our bread and butter. I know somebody mentioned that the Air Force also does a job similar to ours. We have a few capabilities that they don't have. And one of them is that Doppler radar. That is our bread and butter. Everybody wants the information that they gathers, and we're the only ones who have it. Now, the Air Force does have a lot more airplanes than we have. We have 2. This is Kermit, and the other one is Miss Pig.
They've
Yeah,
got
that's what he
10.
mentioned.
They've got 10, but they don't have near the equipment that y'all have on yours.
And they do strictly reconnaissance, or we'll also do research. They have a leg up where they have so many planes that they can stay out there.
Because I get to find the center of the hurricane. Actually use very nice radars to deal with the weather hazards that are out in front of the airplane. A lot of times we have to go through them, but we need to know that we're going through them at a good safe altitude, good airspeed. Basically their approach is airspeed and attitude, let the altitude go where it needs to go. Why stress the airplane trying too hard to keep some magic altitude? The instruments work fine if we're doing roller coaster type of stuff. Once we get inside of the eye wall, then it's a matter of keeping a constant 90-degree crosswind on the airplane, so wind direction changes a little bit, it changes track of the airplane a little bit, it changes back, turn back, hit the 0 wind point, basically make the call to the back of the airplane and drop the drops on and get an accurate surface pressure, generate a vortex message, QC the message, and within a minute or two we can have that up on the satellite comm on its way to the hurricane center. Really don't need to stay in the center any longer than that instant to get the good center fixed data. Continuing the track, mapping the wind fields, and depending on the track that we're asked to do, the typical Reco track that we do puts us in the center about every hour and a half. So however long we're good for fuel, we'll be going in and out of the center every hour and a half. Even though we're required to take fixes generally at the most every 3 hours, I send them a fix every time we go through the center. No point in putting ourselves through that and not putting the information out. So, of course, the real value, along with mapping out the whole hurricane wind field thing, is what is the trend from fix to fix? Is there any sign of recurvature or changing of the track itself? Are there indications of something like rapid intensification, something that Bill Reed worries about a lot down in the Caribbean? Right off of the Florida Peninsula on either side, you can get rapid intensification that you don't get farther north. So this is why we do this repeated, rinse and repeat kind of thing, just back through, and then favoring the area with the strongest winds. So when we get an asymmetrical storm that has a big wind field on one side and kind of a weaker one on the other, we know.
Just still keep on working real well. It's a pretty basic thing, even though it's kind of intimidating. We have 4 engines, so there's a lot of information to repeat. You got engine 1, engine 2, engine 3, engine 4, engine 1, 2, 3, and 4. Like we got 5 fuel tanks. You got a fuel management system, and then here's how you get bleed air from the engines and start them, and that's 4 engines there. So it looks kind of bad, but when you think, it's repetitive.
You guys have been doing it a while, so it's just natural.
Yeah. That's the way it's supposed to work.
How about flying through the outside of the hurricane, though? That's a little rushing.
Yeah.
That probably doesn't go away.
We punch right through into the center, go through the eye wall of this thing. We've been for a few rocky rides in it.
Does it rattle pretty good when you go through the, when you pierce one or go through it?
Yeah, it does.
I know the gentleman back there was telling us that once when he flung a life raft so hard it dented that handrail.
Right. That was Hugo in '89.
Yeah, that's pretty a serious wind.
Off force. Yeah. Usually when you get into the eye, you got a lot of downdraft, and so you end up going down first and then up. So you just watch the radar and just like, okay, here comes the down. So there's the down. You go down 1,000 feet and then come back up 1,000 feet and left, right, side load.
So it's a lot of thinking to do with.
Yeah, you kind of got to think on your feet.
But you have a third person sits.
The flight engineer sits here. Greg Bast and Joe Clipple.
That's his right
down
here?
below. Yeah, this is his stuff here, and then this stuff here. So because the plane was made old, they had more labor involved. Now it will be automated. The seat will be gone. There'll be less switches and knobs, and there'll be more of an automation. It would basically say, I have a problem, do this. It would talk you through the issues.